Measures of location and spread, the standard deviation for ungrouped data. Example 2, we want to work out the standard deviation for this data. So there's a method which involves some summary statistics first. So we need to work out the sum of all these data values. We need to square all of these data values first, and then we need to add all of those squared values together. And then we use the formula for the mean, and then finally the formula for the standard deviation, which involves the mean in its calculation. So we have 6 data values, n equals 6. We add up the data values, that's 30. We square all of the data values and add them up, we get 178. Then to work out the mean, we take sigma x, which is 30, divided by n, which is 6, so the mean is 5. And then we substitute those values into the formula for the standard deviation, and we get 2.16. So the standard deviation here is measuring the dispersion of this data from the mean. Now the mean here was an exact value, which I've used in the calculation here. If this was a non-exact value, I would just use the fraction here at this point to preserve accuracy in the calculation for the standard deviation. Example 3, part A. So data, we're going to do the same calculations in the same order as before, and now we get these values. The standard deviation this time, 5.68. Measures of spread, including standard deviation, are never negative values. There could be 0, but they are never negative. It's worth noting that the units for standard deviation, the mean, and the original data are all the same. So if these values here represent temperature in degrees Celsius, then the mean is 5.5 degrees Celsius and the standard deviation 5.68 degrees Celsius. You can use your calculator to work out your standard deviation as well. So here's the mean, and here is the standard deviation. And if you square your standard deviation, you get something called variance. So that's sigma, this is sigma squared. The variance has squared units. So if we have standard deviation and the original data in degrees Celsius, this would be in degrees Celsius squared. Example 4, so this time we have a frequency table, so we have to modify our formula for the mean slightly and for the standard deviation. So the formula for the mean is telling us that we need to multiply x and f values together, so I need another column here with x times f. For the standard deviation, I need x squared times f, so another column here for x squared times f values. You should memorize these formulae. They are not given in the formula book. So these are the additional columns that we need, and then we need to work out the sum of all of the frequencies, the sum of all of the xf values, and the sum of all of the x squared f values. Then we substitute these summary statistics into the formulae to work out mean and standard deviation. So I've done the table work. So the mean, sigma xf, 654, divided by n, the number of data values is the sum of the frequency. So divide by 55, we've got 11.9. This is a rounded value to 3 significant figures. Now when I'm doing the calculation for my standard deviation, so I've got x squared f, sigma x squared f, 7846 here, divided by n, 55, minus, now for the mean I'm going to use the full exact value, so it's better to stick to the fraction that I had here, the exact value for the mean, squared. Don't use the 11.9 in here, you will lose accuracy on this value here. So 1.12 to 3 significant figures. So again, this value for the standard deviation measures how dispersed or how spread out your data is from this mean value. The larger the value for the standard deviation, the more variation you have in your data, and the smaller the value for the standard deviation, the lower the variation or the more consistent your data is. And using the calculator, we have the mean, we have sigma x, 654, which is the same as this. We have sigma x squared, which is the same as this. We have our standard deviation, 1.12, which we have here.